Hey, it's Moser with your hints on the 4C worksheet. This is number 9, where we have the heaviest train ever pulled by a single engine, which was over 2 kilometers long. That's crazy. Suppose a force, well, that's also crazy, 1.13 times 10 to the 8th newtons is needed to overcome static friction in the train's wheels. We're given the coefficient of static friction, and we want to find the train's mass. Yikes. So we're going to start off with this, of course, a free body diagram so that we can understand the situation. And we've got normal force, force of gravity, force of static friction, which, if we're talking about the force needed to break the train loose and overcome friction, that is going to be equal to the force of static friction max. We know that we have 3 equations that we can work with, and we're going to do numerous substitutions. So let's start with mu s equals Fs over Fn. Now in this case, we've been given mu s, but that isn't enough information to get us Fs. Not yet. So let's go to the x-axis, where we know that until the moment that the train begins to move, the sum of forces on the x is 0. We know that the sum of forces on the x is also equal to the applied force minus the force of static friction, and hey, we were given the applied force. Since it's 0, applied force equals force of static friction. Well, this means we can do a substitution back into the mu s equation. We know that on the y-axis, it's the sum of forces is equal to 0, and it's Fn minus Fg. Fn equals Fg, and of course, Fg is really just mg, so Fn equals mg. Now, you could solve each piece one at a time, but I'm going to really strongly recommend that you do the substitutions. So let's just see what that looks like. To start, we'll take that mu s equals Fs over Fn equation and rearrange it to solve for Fn. Well, because we found that the force applied is equal to the force of static friction, we can substitute force applied, which we were given, into that expression. We now have Fn equals F applied over mu s. Since we know, we've proved by using a sum of forces on the y-axis, that Fn equals Fg, we can sub that in, so we get mg equals F applied over mu s. Now it's a pretty simple matter to solve for mass, because we know the force applied, we know mu s, and of course we know gravity. Happy calculating!